Hello, we continue our course on Introduction to Personality Theory. In last lecture, we considered different theories which belong to biological domain of research in personality psychology. Biological domain mainly focus on genetical and physiological factors which contribute to the personality difference between people. And in last lecture, we mainly considered genetical factors and findings of behavioral and molecular genetics. In this video, we will discuss different physiological theories of personality. And to start, we need to understand the basic assumption of those theories, which they share in common. So the term physiological here refers to the functioning of organ systems within the body. Mainly, we speak about nervous system, of course. The basic assumption here is that differences in physiological characteristics related to the difference in personality characteristics, in behavior patterns. So we assume that physiological differences directly or indirectly influence psychological personality differences between people. So it's quite a simple idea. And it meets criteria of simplicity or parsimony. So here, psychologists and physiologists offer a very simple type of explanation without including more maybe unnecessary concepts and drawing a strict line between physiology and psychology. It has its own advantages because we don't use any additional constructs, but at the same time, it might be sometimes oversimplistic because only physiological difference cannot explain all the personality difference and all the personality processes. So you will see this after investigating and studying those different theories, inside physiological approach. Before we will start discussing those theories, we need to understand which methods of collecting data psychologists use to support their ideas in this paradigm. So first of all, one of the most typical methods used in physiological approach to personality is electroencephalography. So it's technique that records electrical activity produced by the brain's neurons through the use of electrodes that are placed around the research participant's head. So on the picture on the slide, you can see this special hat on the participant. It contains electrodes which detect electrical activity of the brain. When neurons fire and transmit message, they elicit certain type of electrical activity which can be detected with the help of those electrodes and send signals to the laptop with special software of psychologists. EEG can show if a person asleep, awake, or under anesthesia, because brain wave patterns would be different. So it actually gives a lot of information to psychologists about internal states of their participant. Which is more interesting, EEG also can track waves connected to reading, writing, and speaking. So if a participant presented to different types of tasks on their computer, for example, represented on the screen, a researcher can understand physiological processes happening in participants during these task-solving processes. And we can find some physiological correlates of different types of problem-solving and other processes. So actually, psychologists can get a lot of information by utilizing electroencephalography, but it's not a primary method and not the only method which physiological psychologists usually use. So the next one, which is more popular and informative, is so-called functional magnetic resonance imaging, or fMRI. It's a type of brain scan that uses a magnetic field to create images of brain activity in each brain. It looks like a big metal tube with a lot of machinery inside, as represented on the picture, and it gives pictures of the brain, as it also represented on the slide, showing active brain areas. So how does it work? So neurons that are firing, transmitting message, consume more oxygen from the blood. And because they need more oxygen, the blood flow in those areas of the brain intensifies. fMRI detects the amount of blood flow in each brain region and shows which brain regions receive additional blood flow, assuming that it's those areas which are more active right now because they're transmitting a message. So it's an interesting technique. Again, a participant inside this fMRI machine can be presented to different types of tasks, including, for example, calculating something, imagining something, thinking about something, or speaking. And psychologists and physiologists can detect which brain areas are more often responsible for performing those types of tasks. So, and this information can be used later to understand the connections between different brain areas and structures and different psychological mental processes. Actually, quite a nice technique. The only problem is that buying this fMRI can be very expensive, so not all laboratories, unfortunately, have this type of equipment. The next method is called transcranial magnetic stimulation, or TMS. It's a bit different procedure. Again, on the slide, you can see how this machine looks like in real life. So idea here is that magnetic impulse used, applied to the brain of a living person to deactivate small brain region. So this small brain region stops working for a small period of time. And again, participant usually presented with certain type of a task in this situation. And if this brain area deactivated, we can measure performance of this participant. The basic assumption is that if this brain area is important for solving this type of a task, deactivating this area will result in low productivity and low performance. And if performance does not change, probably this brain area is not responsible for performing this type of a task. So this is the main idea of this method. So we deactivate certain area of the brain for a short period of time. It's completely safe. And we make conclusions based on performance and in different tasks which participant is presented to. So this is the basic idea of TMS. Again, it's not a cheap machinery. So if you want to buy this device, not all laboratories have enough funding for that. Though it, again, can provide us with a lot of interesting research information in different research projects connected to physiological psychology. Another technique is called PET, positron emission tomography. This machinery, this device, is a bit more complicated. The method is a bit more complicated than the methods we discussed earlier. So here, idea is similar to fMRI, to make a functional imaging technique which shows in real time like which areas of the brain are more active. But the whole principle is different. PET uses radioactive substances to know what's happening. Again, it sounds dangerous, but it's completely safe for the participant. So here an idea is the following. So radio is a dog attached to a drug which participant drinks, or it may be injected in the body of participant. When this radiopharmaceutical undergoes beta plus decay stage, a positron is emitted, and when the positron collides with an ordinary electron, those two particles annihilate, and gamma rays are emitted. And PET machine actually detects those gamma rays and shows three-dimensional image where it's happening. And the idea is that it's happening in the more active brain areas, and that's how we can detect brain activity. Again, usually a participant presented with different types of tasks, depends on the research design, and we can get some information about that. So PET is less usual as an fMRI in different research designs, but still quite popular. So you can find a lot of articles presenting research which utilizes PET as a technology of getting data. So one more method is called magnetoencephalography, or MAG. It is also a functional neuroimaging technique for mapping brain activity. So because neurons elicit electricity, they also have a small, weak magnetic fields. And magnetoencephalography actually detects those weak magnetic fields that our brain naturally elicits, and uses this data to analyze the level of activity of the participant. Often, MAG is combined with magnetic resonance imaging, MRI. It might be not always functional MRI. So often we can combine those two methods together to get a bit more information about activation of different brain areas. And even before inventing those advanced physiological techniques and devices, psychologists used a bit different methods. It's so-called lesion studies. It's also used in psychology nowadays, though at less extent. So the problem is that a lot of people, due to different circumstances, might get unfortunate brain injuries. Brain can be damaged due to violent crime, automobile accidents, or tumors, or strokes, or other type of disorders. And when brain is damaged, it influences the whole mental abilities of a person. And we can know which area of the brain is damaged and invite a person to participate in research and take a look what are possible consequences of this damage for this person to connect different brain structures and brain areas with certain mental functions. So that's how it was used primarily in clinical psychology. And again, even nowadays, clinical psychologists might utilize these methods. So lesions are those damages of the brain. So we try to connect which structures are damaged and how it influences mental functions and performance of the participant in different types of tasks. So quite a simple idea. So utilizing all of those methods, physiological psychologists created several different theories which try to explain how different personality traits and characteristics might work. And we should consider several of those theories, the most famous one. So let's dive in. And before that, I forgot, we need to consider the last method, which is called electrodermal activity. I'm sorry, forgot about that, but it's still important. So The skin on the palms of our hands has sweat glands, so our hands can sweat, especially when you're stressed and activated. And it's connected to the cycles of arousal and relaxing we naturally have. So this electrodermal activity technique basically detects the level of activation through the electrodermal activity of your skin. Basically, this device can show either a person stressed and activated or relaxed. This is one of the indicators which can be combined with others to get us, as researchers, some useful information about the overall level of activation of the person. Unfortunately, it doesn't show why person stressed or activated, so it's not specific and should be combined with other techniques to provide us with more information what is happening exactly. And now finally, series of personality based on physiology, as I promised. So the first theory we will discuss was introduced by Donald Hebb, Canadian psychologist. He put forward hypothesis that people have so-called optimal level of arousal. It's a certain level of physiological activation people try to reach. So idea was the following. If you're kind of under aroused, your activation level is too low, you seek different types of activities which will increase your overall arousal, returning you back to this optimal level of arousal or like motivation. If you're over aroused, like your activation is too high, you seek different types of activities to decrease your level of arousal to return back to this kind of hypothesized optimal level. So this is like how we motivate it because people want to reach this optimal level. Of course, this optimal level would be a bit different for different people. So it's the source of individual differences between people. Hans-Jürgen Ising, whom we discussed in previous videos, as a psychologist who introduced theory of in dispositional domain, PEN, also tried to use these ideas introduced by Hebb a bit earlier. And in his book, The Biological Basis of Personality, he decided to connect this idea of optimal level of arousal with the factors of introversion and extroversion. So his idea was that introverts initially have higher levels of activity inside their brain. So they kind of initially over-aroused. And because of that, they constantly seek activities to diminish this level of arousal. So that is why they try to communicate a bit less. That is why they like quiet settings more than loud and crowded ones. And that's why they try to decrease this level of activity to return to the optimum. And naturally, they have like a bit over aroused compared to extroverts who have kind of under arousal. And that's why they're seeking more types of activities which will increase their level of activation, including like active sports, more communication, more crowded settings, and so on. So he thought that it's a physiological difference which drives people into those different mental and social activities here. So that was his idea. Ising supposed that it's connected with ascending reticular activating system, ARAS, and tried to explain the difference between extroverts and introverts in terms of physiological difference. That is an interesting idea. Modern findings show that it is probably not true. And the difference between extroverts and introverts probably lies not in the initial level of arousal they have, as Ising hypothesized, but rather in their arousability. So introverts have higher arousability, so stimulation affects them stronger compared to extroverts, sorry. And extroverts have lower arousability. So when some event happens, it increases level of arousal in introverts much stronger compared to the same event, which affects extroverts. And probably this is the difference. Arousability, not initial level of arousal. So it's a difference. But indeed, findings show that if people given a choice what to do next, extroverts tend to seek greater level of stimulation than introverts. It might be more music, more physical activity, more communication, some settings with more sounds and things going on. But if presented the choice, introverts tend to choose situations with lower level of stimulation, while extroverts tend to seek situations with higher level of stimulation, and probably it is exactly connected with their arousability, which is actually a physiological difference. So this psychological trait difference between extroverts and introverts probably indeed have certain physiological basis. Jeffrey Gray, a bit later, tried to hypothesize an interesting construct, after which he created so-called reinforcement sensitivity theory. So what was the idea? Gray tried to construct a model of human personality based on two hypothesized biological systems in the brain. The first system was called behavioral activation system, or BAS, which is responsive to incentives such as cues for reward. And when BAS recognizes stimulus as potentially rewarding, it triggers approach behavior. So it's some sort of accelerator pedal inside our internal car. It motivates us to approach to something and get it. The opposite system is behavioral inhibition system, or BIS. It's some sort of internal brake pedal inside our car. It is sensitive to punishment and frustration and uncertainty. And the effect of BIS activation is that you try to avoid certain types of stimulation and behaviors. So when you feel that it's rewarding, you approach. When you feel that it might be frustrating and cause punishment, you avoid. And those two systems work inside you. So again, it's hypothetical constructs introduced by Jeffrey Gray, but he put forward hypothesis that people naturally differ, and some people have more sensitive BAS, and some people have more sensitive BIS system inside of them. So he tried to create a model with introducing new dimensions of personality, adding something to Ising's theory. So he supposed that we differ not only in extroversion and introversion and neuroticism, emotional stability, as a two primary axis, Ising supposed typical for everyone. He decided that behavioral inhibition system is responsible for anxiety. So people will be more anxious if their BIS system is more active. And behavioral activation system is connected to impulsivity. So people with sensitive behavioral activation system would be more impulsive compared to people with less sensitive behavioral activation system. So this is an interesting idea, right? So if people constantly feel that any type of activity will be rewarding, they become less cautious and more impulsive. And on the other hand, if people consider all the situations and stimulation as potentially threatening, they try to avoid this and become much more anxious, right? So it's an interesting idea. So, and this is the physiological kind of basis of impulsivity and anxiety. Later studies conducted by Gray and his colleagues showed that probably this initial model looks a bit differently. So he started to think that behavioral inhibition system, which he initially supposed is connected to anxiety, is actually much closer to this initial dimension of emotional stability and neuroticism, while his impulsivity axis is closer to extroversion introversion axis. So in his later revisions of this model, Gray supposed that those two dimensions shift a bit and have less difference between extroversion and impulsivity and less differences between anxiety and neuroticism. Another difference between people is their need in new impressions, so-called sensation seeking. In the last lecture, we already discussed this a bit as one of the findings in molecular genetics, that actually there are genes responsible for that and we can detect them. So sensation seeking, usually understood as the tendency to seek out thrilling and exciting activities, take risks to avoid boredom, right? Some people want to jump with parachute, gamble at casino, I don't know, drive cars very fast, right? And involve in more risky activities and sports to avoid boredom, to feel something. While some people don't really like those ideas, and it's like complete overstimulation for them, right? So anxious people, completely opposite to that. They don't like new impressions. They already have enough stimulation as it is. So it's connected to dopamine receptors. So again, dopamine is a neurotransmitter, one of the key neurotransmitters in our central nervous system. So, and research shows that dopamine receptors on specific chromosomes have association with increased impulsivity, including taking drugs and addiction, because, you know, taking drugs and addiction also might be connected with sensation seeking, like people do that to feel something new. It also connected to gambling, mood-related impulsivity, and people probably have a real physiological difference, not only on genetical, but also on a physiological level behind this. Marvin Zuckerman was one of the researchers who started to study sensation seeking. Though initially in mid-60s, he started to research so-called sensory deprivation. Probably you know this concept from the Introduction to Psychology course, but I quickly will remind you that Zuckerman and his colleagues constructed a special capsule. So participants in this capsule were completely lacking any type of external stimulation. So no sound, absolutely dark. Inside there was a water of body temperature, which you don't feel, with a lot of salt. So a person just floats on this water, doesn't feel anything from their tactile reception, no smell, nothing. And Zuckerman and his colleagues figured out that some people tolerate this sensory deprivation better, while some people go absolutely crazy in 5 minutes. So there is a natural difference in people in how they cope with possible sensory deprivation. These observations led Zuckerman and his colleagues to research of sensation seeking. And actually, Zuckerman called people who wants these new sensations high sensation seekers, and people who don't low sensation seekers. So theoretical explanation of this sensation seeking was close to Ising offered for extroversion. And actually, there is a strong positive correlation between extroversion and sensation seeking. It's not fully independent factors. We know it right now. So Zuckerman tried to find this physiological basis for high sensation seeking. And they came to the conclusions that it's connected to neurotransmitters. So neurotransmitters are chemicals in the nerve cells which are responsible for transmission of nerve impulse or message from one neuron to another. Certain enzymes, particularly MAO, are responsible for maintaining the proper level of neurotransmitters. MAO works by breaking down the neurotransmitter after it has allowed a message to pass. So neurotransmitters released in the synaptic gap, it helps to transmit electrical impulse next to activate new neuron and send message next. But those neurotransmitters need to be removed from the synaptic gap so the neuron can fire once again, right? And MAO is an enzyme which basically destroys neurotransmitters in this synaptic gap. If there is too much MAO, it would break down too much of the neurotransmitters, and nerve transmission, would be diminished. So it will affect ability of neuron to transmit message once again. But if there were too little MAO present in the synaptic gap, after that, an excessive amount of the neurotransmitter will be left, so no cleaning in synaptic gap, and it will affect neuron transmission. It would be too excessive, too strong, too much. So in normal cases, we have enough MAO in synaptic gaps, so everything works properly, but there are some small differences between people in the amount of MAO in their synaptic gaps. So high sensation seekers tend to have low levels of MAO in their bloodstream. So transmission of message becomes like too much, too strong compared to people with low sensation seeking who have either enough MAO or too much MAO in their synaptic gaps. According to Zuckerman's theory and research, sensation-seeking behavior are due not to seeking an optimal level of arousal, as some other psychologists hypothesized before, but to have too little of the biomechanical breaks in the synapse. So because they lack MAO, too much neurotransmitters stay into the synaptic gap, and it sends more and more messages, and the message becomes stronger. And those people just can't stop, right? So they lack this natural brake pedal inside their physiological system, which makes them like more active and seeking for more impressions because they just basically have lesser ability to stop compared to people with low sensation seeking. It's actually quite an interesting explanation, physiological explanation of quite a psychological phenomena, right? So other psychologists were also interested in neurotransmitters and their role in our behavior and different cognitive processes, as well as emotions. So, and three neurotransmitters from the whole variety of them received more attention than others. It's dopamine, we mentioned before. It appears to be associated with pleasure. Dopamine appears to function like a reward system and has been called feeling good chemical. It's not responsible for pleasure itself. It's responsible for the feeling that if you continue doing what you're doing, you will get reward or pleasure later. So most of people experience increased level of dopamine by scrolling their social networks. And they have feelings that if they scroll a bit more, they will find something interesting and useful and rewarding, but it never happens, right? So we continue scrolling and continue. So it's motivating, and you feel that soon something good will happen, but dopamine is not responsible for providing you with the feelings that something good. It's just a promise that it will happen. So serotonin connected with the lack of serotonin connected with depression and mood disorders, partially anxiety. And noradrenaline is involved in the activating sympathetic part of nervous system for flight or fight response, right? So with stress and activation. Those three neurotransmitters received more attention of researchers than others for some reason. Cloninger, one of famous psychologists, proposed a three-dimensional personality model in which three personality traits are actually connected with these three aforementioned neurotransmitters. So he supposed that novelty seeking or sensation seeking connected to low levels of dopamine, harm avoidance associated with abnormalities in serotonin metabolism and homeostasis. So people who low in harm avoidance described as energetic, outgoing, and optimistic, whereas people high in harm avoidance described as cautious, shy, and apprehensive. So it, according to Cloninger, is connected with the level of serotonin neurotransmitter. And finally, reward dependence. Cloninger supposed that it's related to low levels of noradrenaline. People high on this trait are persistent. They continue to act in ways that produce reward. They work long hours, put a lot of effort into their work, and often continue striving after others have given up, right? Because they have lower levels of norepinephrine or noradrenaline, which is the same. This theory didn't receive complete recognition among psychologists because probably it's a bit an oversimplification, and we cannot explain a lot of different personality, individual differences only in terms of like neurotransmitters balance. So they coincide and correlate with the difference in personality, but we're not completely sure what is the cause and what is the effects. Effect and relationships are probably a bit more complicated than represented in theories like Cloninger theory. But we also know some other physiological factors which create difference between people. And one of those differences is so-called chronotypes connected with your biorhythms, biological activity rhythms, circadian rhythms. Probably heard about that as well in Introduction to Psychology theory. So, two most famous chronotypes of people are morning larks and night owls, right? So, quick reminder that morning larks are getting up earlier and they feel more energetic in the first half of the day, but they're getting tired very fast in the evenings, and that's why they're going to sleep quite early because they're exhausted at the end of the day. Night owls, on the opposite, they don't like to wake up early, they like to wake up later, and they start to feel a burst of energy at the end of the day, in the second half of the day, at the evening or even night. They're more active, and because of that, they're going to sleep later because they have more energy and they're more productive in the evenings. So, and this difference is also connected with our age. So most of young people around 20 years old are have prone to be more like night owls. But after that, slowly people become more and more like morning larks. And probably you know that most of elderly people are complete morning larks, waking up very early, like 5, 6, 7 a.m., even without alarm, and feeling tired and going to sleep around 8, 9 p.m. is quite typical behavior for elderly people after they hit like 60, 65, 70 years old. So we all slowly moving, even if you're like complete night owl right now, you will be slowly shifting and becoming more and more morning lark when you age. So this is what research suggests. So psychologists try to connect those chronotypes with different personality traits, though those results actually often controversial. I should warn you about that. So some research shows that night owls are smart, creative, and hardworking, but morning larks better at school, more initiative, and more careful with time, and less vulnerable to depression. Again, the results of those studies should be examined very carefully. The problem is that there are a lot of so-called intervening variables. So the chronotype is not the only thing connected to intelligence, creativity, time management skills, or depression. And that's why it's only one of many, many factors which can affect. Thus, those correlations we receive in even good contemporary research should be treated very carefully and very critically. So that's how it works. So, conclusion. What can we say about biological domain of personality psychology so far? So, both genetical and physiological factors really play an important role in personality development. No one can deny that. It's an absolute true, absolute fact. In most cases, the relationships between heritability and environmentality are very complex, right? So, for example, 40, 50, 60% heritable, and 40, 50, 60% are due to environmentality. So relationships are very complex. Genetics plays very important role, but the same important role goes to environment. And as we discussed, environmental factors can be very different, and we can classify them very differently. So to examine those relationships, we need to put a lot of efforts and examine everything very, very carefully. Physiological factors and variables can be seen either as measures which correlate with personality or as factors providing causal, right? So they cause personality difference or they only correlate with personality differences. Both happening depends on different personality characteristics. And finally, there is no single grand theory of personality based on genetic or physiological factors. All theories and research we examined so far were primarily focused on like 1, 2, 3 personality traits. So they do not create any like grand theory of personality which can explain the overall personality, how personality looks and like and operates, and what's the reason behind certain differences. So most of physiological and genetical research focus on very narrow traits or personality characteristics and differences and examines them. So unfortunately, so far we don't have any like major big theory in this domain, which we can use to explain personality in general. In next videos, we'll continue investigating biological domain, and we will talk about evolutionary psychology and its applications to personality psychology, which would be very interesting. So please continue your studies. Thank you.